Hi students. So now we will be seeing IUPAC, how to name it, and then we are also going to see like how to calculate standard electrode potentials, and if it is more negative, so what is the value, I mean whether it can act as an oxidizing agent or reducing agent, those stuffs we are going to see, and also like how we can calculate Ecell, and we will also see like how to construct the standard hydrogen electrode. Okay, now let us see one by one. Okay, in an IUPAC always we should start with anode. Start with anode, double slash, and its solution, then cathode. How to write the IUPAC for the electrochemical cell, we are going to see anode and its solution, because any electrode will be dipped in its own solution. So zinc rod dipped in zinc sulfate solution, then copper rod dipped in copper sulfate solution, for example I am saying. Okay, so how we should write is Zn, it's a solid, right, because it's an electrode, and we should always represent physical state. Okay, Zn 2 plus, or even we can write ZnSO4, nothing wrong in that. Aqueous, because any salt is dissolved in water, am I right? So aqueous. Then we use double slash represent salt bridge. Okay, then we should start with cathode solution, that is copper sulfate, again aqueous, then end with electrode, that is cathode, which is a solid. So IUPAC convention, very simple. We have to start with anode and its solution, double slash, which is a salt bridge, then start with the solution, end with the cathode. Okay, so this is the IUPAC convention. And which one we will take it as anode and which one we will take it as cathode? Always highly reactive metals, always it is taken as anode. Less reactive metal, always taken as cathode. For this you should know reactivity series. Okay, so for you guys I am going to give you that reactivity series. We can say activity series or reactivity series. So this is the reactivity series. It starts with like a more reactive metal, that is lithium, and it ends with less reactive metal, that is mercury. So it is arranged in the decreasing order. Is that okay? So for example, if you take the Daniell cell, so where is Daniell cell? I mean in the Daniell cell, which are the elements we use? We use zinc, we use copper. So where is zinc? See here. Now you see where is copper? Here. Now which is more reactive here? Zinc is more reactive than copper, am I right? So zinc we should take it as always anode, and copper we should take it as cathode. Is that okay? Very simple shortcut. Okay, what is it? Whichever is highly reactive you will take it as anode, and whichever is less reactive you will take it as cathode. And also like funny way we can study this. Okay, like one data is missing here. Lignaka, okay, you can remember like this. Lignaka, Magal zinc, Fepep, Akku, Aggu, Patak. Okay, it's a very funny way. Just say 2 or 3 times. You will never forget this. Okay, so and also it will be very useful for you when we do electrolysis part. Is it okay? So Lignaka, Magal zinc, Fepep, Akku, Aggu, Patak. Very simple. Yeah. So hope you guys understood. So now we will go to IUPAC now. So now I randomly say like which one we can take, and you guys can get the answer out of it. All right. Right. Now let us see. So silver, copper is given to you. Now which will act as a cathode and anode here? Which is more reactive? Copper is more reactive in the reactivity series. So copper is taken as anode and silver is taken as cathode. So Cu solid, single slash, Cu2 plus, aqueous, double slash, Ag plus, aqueous, single slash, Ag solid. Okay. So this is the IUPAC convention for when the copper and silver is given to us. Alright. So this is the IUPAC convention. So any element is given to us, we can note down or tell like which will act as a cathode and which will act as an anode. So whichever is more reactive is taken as anode and whichever is less reactive will act as cathode. Am I right? So now we will see how to calculate E naught cell. What do you mean by E naught cell? E stands for electrode potential. E naught cell is nothing but standard electrode potential. Okay, standard electrode potential. So it's a very simple formula, shortcut formula I can give you. So E naught cell is equal to E cathode minus E anode. This is the formula. Or simply you can remember EC minus EA. This will be the simplest formula. You won't forget also. E naught cell is equal to EC minus EA. E cathode minus E anode. So you can calculate E naught cell in this way, and that naught represent STP, standard conditions. Like say 1 atmosphere and a room temperature. Actually it's supposed to be 273 Kelvin, but we perform the reaction at room temperature. So 25 degrees Celsius and 1 atmosphere, and then if you measure this standard condition, then it is said to be standard electrode potential. Now let us see how to calculate standard electrode potential for Daniell cell. Is that okay? Now let us see that. So minus 0.76 volts is given as 0.34 volts. These are the standard electrode potential values, and also you can see that Zn2 plus slash Zn, similarly Cu2 plus slash Cu. What is the meaning of that? It is called reduction potential. In order to calculate E naught cell, we should always use reduction potential for any calculation. Is it okay? Why I am insisting on this? Suppose if they give oxidation potential, say for example Zn slash Zn2 plus is given to you, you should always reverse the sign and take for the calculation. So we should always use only reduction potential. Okay, and one more thing to avoid confusions. Okay, one if you take oxidation, one if you take reduction potential, and then you will end up with the wrong answer. So better always to take only reduction potential and calculate. Is it okay? Suppose if they give oxidation potential, what we are supposed to do? We have to reverse the sign and then take. Is it okay? So now let us see how to calculate E naught cell for the Daniell cell. Okay, so let us see. So E naught cell is equal to EC minus EA. We saw the formula, no? So what is EC here? Which is cathode here? Zinc is there, copper is there. So which is cathode? Copper. Am I right? Which will act as anode here? Zinc. So cathode minus EC minus EA. So copper minus zinc. That's it. Now let us take the value 0.34 minus of minus 0.76. So 0.34 plus 0.76, which is nothing but 1.10 volts. Okay, this is the answer. So how to calculate E naught cell? EC minus EA. So any given cell to you, we can always calculate E naught cell. Just we have to remember this formula. What is it? EC minus EA. Now I will give one more cell. Okay, I will give you an IUPAC convention and you guys can calculate and let us discuss the answers further. Alright. Okay. So E naught cell is given 0.80 volts. E naught of Cu2 plus slash Cu is equal to 0.34 volts. Now calculate E naught cell. Calculate E naught cell for this. Now we can think about which is acting as anode here and which is acting as cathode here. So here copper is more reactive, so copper will act as anode, and silver is less reactive, so silver will act as cathode. Okay. So now we know the formula. What is it? EC minus EA. So which is a cathode here? 0.34 minus of minus, okay, it's not minus, it's only 0.80. Now which is acting as cathode here? Here the cathode is silver, am I right? So now we have to write in a reverse way, right? So which is a cathode here? Silver. So 0.80 minus of minus 0.34. So we don't have minus here. So 0.80, 0.34 subtract. So you will get 6. 7 minus 3, 4. 0.46 volts is the answer. Okay. Once again I will repeat here. E naught of Ag plus slash Ag is 0.80 volts and E naught of Cu2 plus slash Cu is 0.34 volts. Now we know that E naught cell is equal to Ec minus Ea, and here which is acting as a cathode? Silver. Which is acting as anode? Copper. So it is always Ec minus Ea, that is silver minus copper. So silver is 0.80 minus 0.34 for copper. So you subtract it and you get it as 0.46 volts. Is that okay? Understood? So in this way we can calculate E naught cell for any given cell. They can even give you the IUPAC convention and and the values. So values we need not mug up, it will be given in the question. Alright. So then we can use this formula Ec minus Ea and then calculate electrode potential, standard electrode potential. Is that okay? So next we are going to see how to calculate Ecell. So in order to calculate Ecell, we have to use Nernst equation. Okay. So now let us see what is Nernst equation. E cell is equal to E naught cell minus 0.0591 by N log of oxidized by reduced. So this is called Nernst equation. E cell is equal to E naught cell minus 0.0591 by N log of oxidized by reduced. It's a very direct formula. We have to use this formula and calculate. Now let us take one example and explain you how to calculate E cell. Okay, ba? So here what are the information should be given? You should know what is N. What is N here? N is nothing but number of electron transfer. For example, let us take Daniell cell itself. So in a Daniell cell, how many electrons lost from zinc? 2. How many electrons gained by copper? Again 2. So how many ever the electrons is lost, the same electrons will be gained. So what I am trying to say is, N you can identify what is the oxidation state difference, okay ma'am, and the same electron difference only will come in the reverse also. That is, anode and cathode, it will be the same number of electrons gained and lost, okay, that is N. And what is E naught cell? You know how to calculate. E naught cell is a standard electrode potential, and we should use the formula EC minus EA to calculate E naught cell. And then oxidized by reduced. So whichever is anode, you will take it in the numerator, and whichever is at cathode, you should take it in the denominator. Alright. So now let us, I will give one example and explain you how to calculate E cell. So what is the difference between E cell and E naught cell? So E naught cell is at STP and E cell is at experimental condition. That is the only difference. Okay. So now let us take one example and see how to calculate E cell. So you know that E naught cell for Daniell cell will be what ma? 1.10 volt. And what is the redox reaction basically which is occurring? Zn plus, I am just writing the ionic equation, Zn2 plus Cu. Okay, Zn plus Cu2 plus gives Zn2 plus Cu. Now we are going to calculate N factor or number of electrons transfer. So here, as the metal, the oxidation number for any metal, any element in naturally existing state will be 0. So now you take it as 0. And here it is 2 plus. So 0 to 2 plus. What is the difference? 2. Now you take this, so 2 plus is already there, and Cu is 0. Correct? So what is the difference? 2. So I told you earlier, how many electrons is lost? The same electrons will be gained. Okay. So now, so N is 2 here. Okay. And the ions is given, like Zn2 plus ion is given as, say for example, let us take 0.1 volts. Okay. And for copper, 0.01 volts is given like this. Okay. So now how to calculate E cell? So E cell is equal to 1.10 volts, right? So E naught cell minus 0.0591 by 2. Am I right? N is 2. So 0.0591 by 2 log of oxidized by reduced. Now here which is oxidized? Zinc is oxidized. Which is reduced? Copper is reduced. So now we are going to substitute it. So 0.1 divided by 0.01. Okay. So now we can cancel this. 0.0295. Okay, 0.0295. All for simplification, you can even simplify that or round it off to 0.03. Okay, ma'am, so that our calculation becomes little more easier. And also you can convert this into power so that the calculation will become easy. So 1.10 volt minus 0.0295, I am taking it as 0.03. Okay, not much difference will happen, in the answer. So log, so 10 to the power minus 1, right, divided by how many shiftings here? 2 shiftings. So 10 to the power minus 2. So you can cancel. So what will be remaining there? 10 to the power minus 1 in the denominator. Now you take that to the numerator. So it becomes log 10. So 1.10 minus 0.03 into log 10 is 1. Okay. Now if we subtract 1.10 minus 0.03, we will get the answer. So 1.10, 0.03. So the answer is 1.07 volts is the answer. Okay. So once again I will explain this. Now actually we are calculating for the Daniell cell where the concentration is given. N and all they won't give you. You should calculate like this. So what is the difference? Zn to Zn2 plus 2. Cu2 plus to Cu is 2 again, and then E naught cell is equal to 1.10 volts, that you know, and N is 2, Zn 2 plus is given as 0.1, and Cu2 plus is given as 0.01 volts. Now we are substituting in the equation, Nernst equation. So E cell is equal to E naught cell minus 0.0591 by N log of oxidized by reduced. You substitute all the values, simplify it, finally you are getting it as 1.07 volts. So this is nothing but E cell for this question. So likewise they will give you the datas. This also either they will give like this, or they will give you the electrode potential for zinc separately, copper separately. You have to subtract, you have to use the formula Ez minus Ea and then calculate E naught cell and then substitute in this Nernst equation and then calculate. So this is nothing but what? Nernst equation. Okay, understood how to calculate? Yes. So any given question can be solved. So whether it is CBSE or any competitive exams, definitely you can expect questions from this. Okay. So now let us move on to construction of standard hydrogen electrode. So that is what we are going to see now, standard hydrogen electrode. So in a short way we say it as SHE, is nothing but standard hydrogen electrode. So for this we should take a beaker containing 1 m HCl, okay, 1 molar HCl, and then we should take a platinum electrode, okay, platinum electrode, and then we have to use the experimental, the STP. What is STP? Pressure is 1 atmosphere, okay, but temperature actually it is 273 Kelvin only, okay, but sometimes we use 25 degree Celsius for the calculation. And then see, now a glass tube, which is fixed like this, and we have to pass hydrogen gas, okay. So when you pass hydrogen gas, what will happen? Bubbles will be formed, okay, bubbles like this is formed. This experimental setup is called what? Standard electrode potential. So why it is so special? Because it's a reference electrode. You can connect this SHE, that is standard hydrogen electrode, to the anode or to the cathode. Either way you can connect. How you can connect like that? Because its E naught cell value is 0. So E naught cell value will be 0 for this, okay. Since E naught cell is 0 for this, you can connect either side, anode or cathode. So how do you think the value for zinc, Zn 2 plus slash Zn is minus 0.76 volts? How do you think they got the value? It's an experimental only. So the SHE, zinc and hydrogen, if you compare, zinc is more reactive. So you will take zinc as anode and hydrogen SHE at cathode. And if you measure, whatever the answer you are getting, whatever the value you are getting, that will be for zinc electrode. Similarly, if you want to find the copper value as 0.34 volts, how did they get? So they connect copper. So hydrogen and copper, if you compare, definitely copper is less reactive than hydrogen, right? So you should connect SHE at anode and copper at cathode. So whatever the answer you are getting is for copper. So likewise, so that is why it is called reference electrode. There are so many reference electrodes, okay, but here we are fixed to this SHE. Alright, understood? So this is the construction of SHE. So where you are taking 1 m HCl and then platinum electrode, and you have a glass tube where the hydrogen is bubbled, and you have a STP condition, 1 atmosphere and 273 Kelvin, okay, but we use the room temperature 25 degrees Celsius. And so this setup is called SHE, its E naught cell is 0. Only for this reference electrode, E naught cell is 0. Otherwise, definitely any other element, definitely it will have some values. But for SHE, it's going to be 0. Alright? Understood everyone? So what is E cell, how to calculate E naught cell, everything. Am I right? Thank you students.